NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams. And all these little dots are stars?
All these little dots are galaxies, some of which are bigger than our own.
Breaking news. We may have just found potential evidence of intelligent life beyond Earth.
This is a huge discovery, and we think that it's a huge discovery. And that's the most exciting piece of this telescope, of this remarkable instrument we put in space, is finding things that we didn't expect, that we can't explain, because that means that we have to revise our understanding of the universe.
Well, JWST is so phenomenal that if you spend enough time, you could probably find any galaxy that ever formed in the universe. It's really that powerful.
The Leave Plan of Room specialists has found that using our new $101 billion toy, it will be clearly everlastingly before that endeavor changes into a reality. On the slim chance that it goes as coordinated, the trip to Proxima B will take nearly 20 years. So, sensibly, it will be a seriously drawn-out period of time before we can expect to confirm if there is life on that planet. The DST flushed deals of whether we are genuinely alone in this universe progresses onward. Through the James Webb Telescope, it has discovered some unfathomably humanesque things far away from Earth that lead us closer to the answer. Our central goal for life beyond us has been uncontrolled throughout human history. So much so that we have endless media works and speculations concerning this matter. Our wonder about our place and significance in the universe has been persistent. It is embedded within us to constantly look for a mate. Despite how similar we might be, we could get closer to the answers we genuinely seek. But how are they, in fact, the answers we are looking for? Or are they simply unsettling? Join us as we analyze the most recent discoveries in the study of planetary systems and exoplanets on the journey to find something we may not be prepared to see. The search for lights far away. Experts have found what could be the most critical revelation in history. Back in 2021, when the James Webb Space Telescope was set to launch, an extraordinary speculative interest was raised about the limits of our technology. The question was whether, in the future, our telescopes could detect artificial light on another planet. For instance, Proxima B, the nearest exoplanet to Earth. Proxima B, about 4.25 light-years away, was found to be tidally locked, with a continuously illuminated day side and a perpetually dark night side, much like our moon. A hypothetical technological advancement for Proxima B could involve transferring power and energy from the day side to the night side using photovoltaic cells that generate electricity from starlight. In a paper with Manusvi Lingam as one of the researchers, it was suggested that a widespread network of solar panels on Proxima B's day side could be detectable with future telescopes. Since the JWST is an advanced instrument, it allows us to expand our search for artificial lights on exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope accomplished precisely that in 2024, using its higher sensitivity and advanced capabilities, is significant. The JWST may have found the lights we were searching for and could have propelled us into a new era of human discovery. So, let's delve into the universe of planets and exoplanets to understand how this was even possible. James Webb's mission investigates Proxima B. Since the dawn of recorded history, humans have pondered the mysteries of the universe. Who we are, where we come from, and where we are going. These are fundamental yet incredibly complex questions that humankind has sought to answer ever since we gained consciousness. In this era of remarkable technological advancement, one may wonder whether we are any closer to finding these answers. If you were to ask a philosopher, they might say we are still at level 0 in understanding ourselves and the universe. However, ask a space scientist the same question, and you'll see their enthusiasm as they eagerly share the latest discoveries about the cosmos. These scientific instruments, though often overlooked by the general public, are a direct reflection of human progress. Today we have the world at our fingertips, and it is time we extend our reach to the universe as well. One of the most promising ways to do so is through the continuous improvement of space exploration technology. A crucial development in this effort is the discovery of what might be artificial light on another planet, light-years away. Without a doubt, we are discussing the James Webb Space Telescope. The James Webb Space Telescope and the search for exoplanets. The James Webb Space Telescope is the result of decades of human effort in space exploration, designed to answer some of the most profound questions. Are we alone? Who or what might be out there? Where does our story begin and where does it end? This infrared astronomy instrument has already begun addressing these mysteries. If you are unfamiliar with Proxima B, let's clarify. Proxima Centauri b, or simply Proxima b, is sometimes referred to as Alpha Centauri. It is a super-Earth exoplanet orbiting an M-type star. The term super-Earth may sound misleading, but don't worry. This text will answer all your questions. Super-Earths are a class of planets that are more massive than Earth but less massive than ice giants like Neptune and Uranus. They can be composed of gas, rock, or a combination of both. Their sizes range from twice the size of Earth to several times its mass. Proxima b, specifically, is both a super-Earth and an exoplanet, meaning it orbits a star outside our solar system. The first possible detection of an exoplanet occurred in 1917, though it generated little interest at the time. The first confirmed discovery came in 1992, which left scientists astonished. Another exoplanet first detected in 1988 was officially confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems, with 896 of those systems hosting more than one planet. These remarkable discoveries revolve around M-type stars. To understand what an M-type star is, you need to grasp the concept of red dwarfs. A red dwarf is the smallest type of star in the main sequence, hence the name. In the Sun's neighborhood, red dwarfs are by far the most common. A normal sort of star considered in the Milky Way, they have outstandingly low sparkle. Since brilliance is one of our primary instruments for planet disclosure, red dwarf stars are challenging to see. These unnoticeable stars have variable definitions and names, relying upon their temperatures and sizes. For instance, M dwarfs or M-type main sequence stars yield a maximum temperature of around 3000 K, thus getting their name. Concerning Proxima b, its mass is known to be approximately 1.07 Earths. Peculiarly, it only requires 11.2 days to complete one orbit around its star, compared to our 365.25 days. You can estimate the size of the star Proxima Centauri by considering its total electromagnetic range. The star has a total brilliance of only about 1.6% of that of the Sun. Furthermore, in the visible light range, its brightness appears even lower. It shines only 5 to 6% of the Sun's luminosity, emitting far less light energy. More than 85% of its emitted energy is in the form of infrared radiation. Orbiting at about 0.045 to 0.056 Australian dollars from its star, Proxima b's discovery was announced in 2016. You might ask, with so many stars, planets, and galaxies in the universe, why is Proxima b of such great interest? There are a few reasons. Specifically, Proxima Centauri is the closest known star to our Sun. Although 4.2 light-years is a vast distance to us Earthlings, in the grand scheme of the universe, it is just a small blip. So why is Proxima b, our closest known exoplanet, high on the priority list? Right now, it is part of the Alpha Centauri triple star system. Despite Proxima Centauri's very low brightness, the system itself appears as one of the brightest celestial bodies in the night sky, ranking just behind Sirius and Canopus. However, the most intriguing thing about Proxima b is that it could actually be habitable, as it falls within the habitable zone. The possibilities surrounding this star are endless, which is why astronomers have taken on the task of researching its habitability. That's where the James Webb Space Telescope, JWST, comes in. The four primary objectives of the JWST are: 1. To search for light from the first stars and galaxies formed after the Big Bang. 2. To study the evolution and development of the universe. 3. To understand star and planet formation. 4. To examine planetary systems and the origins of life. As the JWST continues its study of Proxima b, we move closer to significant discoveries. From searching for exoplanets to seeking extraterrestrial life. The search for extraterrestrial intelligence. What exactly is SETI? Given that humans have always been a curious species exploring everything around us, it makes sense that a mission like this would exist. Imagine that God, or nature, has shaped an incomprehensibly vast universe, and we are the ones searching for signals. More specifically, we are searching for electromagnetic whispers from advanced civilizations, far beyond anything we could imagine. SETI, short for the Search for Extraterrestrial Intelligence, is like the world's highest-stakes game of hide-and-seek, with our team as the seekers and the vast universe as the seemingly endless hiding place. This cosmic sleuthing began in the 1960s, when Frank Drake, a renowned astrophysicist, was among the first to detect radio transmissions from the stars. It was a groundbreaking moment, though no aliens arrived at his doorstep, at least not yet. Searching for something this monumental requires patience, spanning not just decades but potentially thousands or even millions of years. Despite many efforts, few definitive extraterrestrial signals have been found. However, the excitement continues to build, as the JWST keeps exploring exoplanets like Proxima B. A whole field of hope is emerging. Will we accidentally stumble upon confirmed evidence of extraterrestrial life? Or will we only find tantalizing hints just beyond our grasp, leaving us with more questions than answers? The discovery of artificial lights on distant exoplanets could mark the next chapter in humanity's endless curiosity. Are we alone in the universe? As the James Webb Space Telescope continues to examine the skies, its discoveries will undoubtedly spark further discussions, debates, and perhaps even challenges to our fundamental understanding of life, intelligence, and the nature of the universe. The implications of such discoveries go far beyond curiosity. They hold the potential to reshape our philosophical and scientific frameworks. For example, if we were to confirm that Proxima B or another exoplanet harbors some form of life, it would force us to reconsider our place in the universe. Could life elsewhere develop in ways similar to our own, or would it present a completely new kind of existence? Would it follow comparable evolutionary paths, or would its biology and consciousness challenge everything we know about life on Earth? Even if we failed to find direct evidence of intelligent life, the mere fact that we could detect artificial signals or lights from distant worlds would still have profound implications. It would suggest that intelligent civilizations exist out there, possibly capable of altering their environments in ways that we can observe from afar. This would imply that intelligent life is not an anomaly, but perhaps an inevitable outcome of certain conditions in the universe. What comes next? Still, it's essential to stay grounded and cautious in the face of such potential discoveries. While the prospect of finding life beyond Earth is thrilling, it also raises an important question. What happens next? How would we respond to the confirmation of extraterrestrial life? Would we approach it with respect, curiosity, and scientific patience, or would such revelations spark fear, panic, or even geopolitical conflict? History has shown that humanity's reactions to groundbreaking discoveries, especially those that challenge deeply held beliefs, can be unpredictable. We must also consider the ethical aspects of our curiosity. If we do, in fact, find evidence of life, especially intelligent life, what would that mean for our responsibility as stewards of our own planet? What moral considerations should guide our interactions with different forms of life, whether microbial or advanced? These are not easy questions to answer, and they will likely remain at the center of discussion as we continue to explore the universe. The future of exploration. The search for life beyond Earth, driven by instruments like the James Webb Space Telescope, represents a fascinating intersection of science, philosophy, and humanity's future. Whether or not we find extraterrestrial intelligence, the journey itself expands our knowledge and understanding of the cosmos. One thing is certain. As long as we continue looking up at the stars and asking big questions, the quest for knowledge will never end.